Okay, so hello and a warm welcome to everybody joining us today for this week's ISNTD Connect session. A warm welcome, I was going to say. It's quite a mild day here in London, but I'm very happy and honored to be joined today by Professor Robert Colebunders of the University of Antwerp. Before we come to Dr. Colebunders' presentation, I just wanted to kind of introduce the session somewhat. It's been quite an amazing start to 2021 in terms of NTDs. As you all know, we just had the launch of the WHO's NTD roadmap to 2030 last week. We've had World NTD Day on the 30th, the second World NTD Day. We were all behind that in terms of one of the 270 plus organizations backing that. So it's been quite an interesting start to 21. And also what we wanted to kind of do in this session is to just look at the strategic guidelines, the kind of strategic shifts underlined by the WHO's NTD roadmap itself and apply them to this particular phenomenon. The session today is really looking at the relationships between nodding syndrome, epilepsy, and onchocerciasis, and just to really apply those shifts to see what they mean to this particular phenomenon. I mean, it's been documented since, I think, 1938 in terms of as a phenomenon itself. It's not on the actual NTD list itself, the associated epilepsy. However, there is prevalence in certain areas in terms of foci appearing and have been looked at in some detail for some time now. We just wanted to open that up. For those of you who don't know, onchocerciasis, it's commonly known as river blindness. The parasitic worm involved in that is the Onchocerca volvulus. The transmission to humans is really through exposure in terms of bites, repeated bites of infected black flies from the genus Simulium. They tend to breed near fast-flowing rivers. The symptoms, I mean, I'm sure Robert is going to go into that in some details. Severe itching, skin conditions, visual impairment leading to permanent blindness. There's been some great strides forward in terms of the mass drug administration, the community-directed treatment programs using ivermectin. It's one of the core strategies to alleviate the disease burden. Really, up to now, 4 countries, according to the WHO, have been certified to be free of onchocerciasis: Colombia, Ecuador, Mexico, Guatemala. And then recently we've had countries such as Venezuela, Uganda, and parts of Sudan where certain parts within those countries have, kind of put into place post-treatment surveillance and reporting back very positive results. However, there is this issue in terms of this onchocerciasis-associated epilepsy. Mechanisms are very not really well understood, I'd say. There are kind of hypotheses forward in terms of microfilary present in the kind of central nervous system of the humans, the human immune response itself, and potentially even sleep deprivation due to the intense itching. These are some of the kind of theories that are being put forward, and that's as recent as 2019 in journals such as the Lancet Infectious Diseases, where these kind of mechanisms of action have been put forward in terms of supporting a relationship between this onchocerciasis and the development of epilepsy. So it's a very interesting kind of area, and one that I think does deserve to be opened up somewhat. And I think as I mentioned earlier, the 3 shifts in focus of the WHO's NTD roadmap itself do lend themselves to some form of kind of opening up or unpacking of this. And by that I mean the 3 shifts really, as I'm sure you all well know, moving in terms of accountability, in terms of programs, looking at moving from kind of an action measure to a more kind of impact measure. This kind of, we'll look at this in the Q&A in further detail, but that's one of the shifts. The other shift, moving from vertical approaches to a cross-cutting approach. The entire pediatric epilepsy world that's out there, there's a potential road to partnership there, data sharing, all sorts of overlaps in terms of that particular shift. And then you've also got this kind of move from external-led experts to a more country-led, local, sovereign-owned program or concept, as it were, approach. And so those three shifts we think are really going to be, they really speak to this particular phenomenon. And it'll be very interesting to see how this presentation goes. Before I continue, I'd just like to say, could I just ask everybody to just throw in, a lot of people are already saying hello in terms of their country, their organization name, organization and country. We've got New Jersey, West Wales, Uganda. We're getting shouts out from Tanzania. We're getting Somalia, Canada, the Canary Islands. Hello to everybody there. Brazil, Madagascar from the Institute Pasteur there. So we're getting a wide array, as we always do. I'm proud to say that on ISNTD Connect, from a huge array of countries. One last point from myself, and that is there might be some bandwidth issue. We were testing the lines out. So what might happen is that Professor Colebunders' face might just, has just done there on cue to the icon, but his presentation won't be affected and you'll still be able to hear him. He might come in and out on that basis. Don't worry, it's all there. I think that's enough from me. So Professor Colebunders, if I could ask you to just launch your slides, if that's possible, on a 3, 2, 1 basis, and I'll kind of back out. And I'll rejoin you for the Q&A. And please keep the questions coming. I'm backing out. Thank you very much. Thanks a lot. Over to you.
Good afternoon, everybody. Very happy to be with you. And thanks, Cameron, for this introduction and putting everybody aware about onchocerciasis. And I'm talking to an expert group now, I consider. So, but I will consider to talk about nodding syndrome and onchocerciasis-associated epilepsy, what I believe are two very important public health, but very neglected public health problems. And I hope I could convince you after my talk that really we need to do something about it. And we can do something about it. So first, some introduction about nodding syndrome. What is nodding syndrome? Is a kind of epilepsy. And it's generally associated with intellectual disability. Often the children are stunted, and they have, some of them have failure to develop secondary sexual characteristics. These children in general develop these seizures, the first seizures when they go to primary school, and they previously have been completely normal. They had no problems at birth. There was no development problems. And then around the age of around 8, 9, 10, they developed this type of epilepsy. So you see, in 2012, it was considered in science as a mysterious disease. And if you want, you can look at the YouTube video, how terrible this disease is. So, but it was considered as a mysterious disease, and I hope that you will be convinced that a lot of progress has been made since then. So in 2013, it was considered it only was present in 3 countries, and that was Uganda, it was South Sudan, and Tanzania. And there were a lot of hypotheses at that time that were investigated, such as infectious causes, toxic causes, nutritional factors, for example, fungal toxins in contaminated food, psychosocial factors, and genetic factors. But none of these factors were confirmed in this research. The only element that was really found to be linked with nodding syndrome was the fact that there was a link with onchocerciasis or river blindness. However, it was not considered at that time, in 2013, that onchocerciasis could be the cause of this nodding syndrome. And what were the reasons? The first important reasons was that it was never considered that the worm was entering the brain. the small worms that are produced by the mother worm, they go into the skin and they cause skin disease, and they go into the eyes and cause eye disease. And you have the adult mother worm who is in the nodules. But it was considered as a disease of the skin and the eyes, but not of the brain. And it was also put forward that nodding syndrome only is occurring in those 3 areas, onchocerciasis areas in 3 countries. And why, if it is related with onchocerciasis, why is it not occurring in other countries? So in 2015, I got a grant to do a more in-depth investigation of this type of epilepsy that is occurring in onchocerciasis endemic areas. And instead of looking at only one country, I wanted to look at the problem more broadly in different countries, and also to use a multidisciplinary approach and doing epidemiological studies, eco-entomological studies, and lab studies, and to see what the cause could be and how we could stop this nodding syndrome epidemic. And I will present most of my research now in the following minutes. So if you want to look at the association between onchocerciasis and epilepsy, you have to go to the places where onchocerciasis is most prevalent. And that is clearly in the Democratic Republic of the Congo. And on this map, you see on the right side a rainbow map. That is very well known among onchocerciasis experts as a map where you can see the places where there's most onco-transmission, and those places are in dark brown. And you see many areas in the core of Congo are dark brown. So I went to these places. Particularly, I went to the Oriental province. At that time, it's in the north and the east of the Congo. Went to several places, Kisangani, Tutule, Bunia, where we were going to look whether there was also epilepsy in those areas. And we took a 2-step approach. So we went from village to village and from house to house with village health workers to screen the houses for presence of people with epileptic symptoms. And we had a very simple questionnaire with 5 questions. And if one of those questions was positive, for example, some convulsive manifestations of one arm, okay, if the answer was positive, then the person had to be seen by a medical doctor. And in some cases, we also had a neurologist with us to confirm the diagnosis. And these are some of the results in the Congo in those in 3 provinces. And you see that in all those provinces, in these villages, there is a very high prevalence of epilepsy. That is going from 2% to 7, 8%, 6% in some areas, while the median epilepsy prevalence in Africa is 1.4% in overall, everywhere in sub-Saharan Africa. This is like 4 or 5 times higher in onchocerciasis areas in those places in the Congo. And not only we found this high prevalence, but also some explanation, possible explanation for it. For example, in Draju, there was never any ivermectin given. So there is still high transmission, in that area. In Aketi, in Bauele, there was already a program for distribution of ivermectin since a long time, but there was extremely high exposure by black flies and not a perfect coverage of ivermectin. And that was also the same in Chopo, where it was very clear that the ivermectin was not used in a proper way. They used it mainly also to eliminate the parasites of their hair, and not to take it by mouth to kill the microfilaria. And in those places, we found mainly people with generalized tonic-clonic seizures, sometimes cases with nodding syndrome, and also sometimes children, in fact adults, with Nakalanga syndrome. This is, for example, the person in the middle here on the figure is a boy of 20 years old, and he is only 1.41 meters. His brother, who is younger, who is 70 years, is next to him and is much, much bigger and larger. And he is nearly a child like the one on the other side. That family was living in a village close to the Kuda River. It's a rapid flowing river, and this is a site where you have black flies that are breeding, and so this child had been infected with Onchocerciasis volvulus, and indeed that was also shown in his skin. When we did a skin snip, we found extremely high load of microfilaria, so the small worm caused by the onchocerciasis was extremely present in that young boy and was most likely the cause of his condition. We did also a case control study, and also other researchers have done case control studies concerning nodding syndrome. That's something, one of the first types of research you're going to do if you want to look at a relationship between two conditions. But some of the case control studies showed an association, other not. And what is the reason? The reason is shown on this slide. The reason is that ivermectin can be a confounder. You have to take into account whether in the area ivermectin has been distributed or not. And that is illustrated by the fact, if you look at Draju, Logo, Ituri, there you see that there is a clear difference if you compare the cases with the controls, that, for example, skin biopsy, that twice as many cases had parasites in their skin among the cases than the controls, and they had also more than 10 times more microfilaria in their skin than the controls. And also they were more positive for antibodies against Onchocerciasis volvulus. And this is in contrast with Chopo. So the other site where we did a case control study. In Logo, there has never been any ivermectin given there. For a reason is not clear. But in Chopo, they had already since many years, about 13 years of ivermectin distribution there. But the problem was that the persons were not taking it very well. But what happened is that the persons with epilepsy, they take it because they were taking it because they also had itching caused by onchocerciasis. While the healthy people who have no symptoms, they were not motivated to take it. Moreover, persons with epilepsy, they avoid going to the river because they can be drawn in the river. While healthy persons, they go swimming because there's no problem. So you see that during the life of a person with epilepsy, everything changes. And then the ivermectin, that clearly it has an effect on the number of microfilaria in the skin and on skin positivity. That is a confounder, and it's explaining that only case control studies done in areas where there's no ivermectin distribution can give you reliable results concerning the association between onchocerciasis and epilepsy. Now, there is something other that is very specific in people with epilepsy in onchocerciasis areas. What is very typical, that is that the epilepsy starts around the age of 8, 9, 10 years old. And this is an example of Ituri. And you see that if you look at the prevalence in an area where there's no ivermectin, and you look at the prevalence per age of epilepsy, then you see two peaks. One peak in the very young children, but you see a very important peak in the children with the age 10 to 15 years old. And in fact, you see that in that area in Ituri, 31% of the epilepsy was in the age group between 10 and 15 years old. And this is in very much contrast with areas in sub-Saharan Africa where there is no onchocerciasis or very little. And here you see 5 examples of areas. These are demographic surveillance sites where they have done also door-to-door surveys of epilepsy. And you see that in those areas, you see the peak of prevalence of epilepsy in the very young ones, below the age of 5. But you don't see any peak in the age group 10 to 15. That's missing there. So here you see the first peak is the epilepsy caused by peri-delivery anoxia, and some because of cerebral malaria, so in young children. But you don't have this peak later in young children. And what is the explanation of this phenomenon in onchocerciasis areas? My hypothesis is that this age group between 3 to 18 is really the age group where, if you are infected at a young age with onchocerciasis, the number of microfilaria in your skin and in your body is going to increase very rapidly. And so that could be the trigger of the epilepsy. When you arrive at a certain threshold, the child may develop epilepsy. Some children will never develop it because in all infectious diseases, some people escape the disease because of genetic and immunological reasons. It could be also that in that area or in that age group, the brain of young people is very more susceptible for developing epilepsy. And we see also in Europe that there are children with juvenile epilepsy, and these are often also of unknown causes. That has nothing to do with onchocerciasis, but the brain of these young children may also be more receptive for developing epilepsy. Now, if onchocerciasis is related with the cause, I'm not saying the cause, but they are related to, or certainly a factor playing a role, then you should see it appearing in places where there is no onchocontrol. And in fact, that is what happened in Sudan, where you see again here a rainbow map, and you see the red area there. That means red area means a lot of people with nodules, so it means a lot of transmission of onchocerciasis, and it means also an area where ivermectin should be distributed to the population every year. But you see here in the green area, and that are districts called Pader and Kitgum, that was a green area. So it means that it was considered at that time, so in 2008, of an area where there was no reason to give ivermectin. Maybe that was not explored very well what the situation was of onchocerciasis there, but there was in fact no onchocerciasis. It was also an area where there was insecurity, then there was a war, and people were put in IDP camps. So initially there was no ivermectin distribution there. What happened is that there we have seen an epidemic really of nodding syndrome. And you see here the localization of the cases in black in those 2 green areas. Here we have now these cases of epilepsy. And if you look then at the rivers and the localization of these cases are close to the Pader and the Ashwa River. And here you see in red, the red dots are the black fly breeding sites. So really these cases appear in places where there were black fly breeding sites. And here you see the epidemic of nodding syndrome in blue, but you see also convulsive epilepsy increasing in red, and in the same way in those 3 districts. So it's clearly the same relationship between nodding syndrome and these other forms of epilepsy is coming up in the same area and also increasing in the same way. And that is in fact indeed the case. If you look at nodding syndrome, it's only the ears of the hippo. The hippo is what is below the water, but that's very big. And that is onchocerciasis-associated epilepsy. It's the epilepsy that's triggered by the onchocerciasis. And in fact, is a huge problem in the DRC that was not known before. And we see in many of the households, we see nodding cases, but we see often these have siblings with other forms of epilepsy. So you cannot consider that there are two diseases in that same family. These are really have the same condition, but there are indeed factors playing a role. And I think it's probably the amount of infection that the children have that is causing the nodding syndrome. They're more severely ill, they're more infected, and have higher microfilarial load. And as I've shown the example of the Nakalanga case in the DRC, they have very high levels. And at a young age, then you develop nodding syndrome. And if it's less, you're less infected, you may develop another form of epilepsy. But it is still a little bit difficult to understand why suddenly there appeared about 20 years ago or more, these epidemics in northern Uganda and South Sudan. And this, there are different factors that may play a role, and they may be different in one country to another, and they may play a role at the same time. And for example, in Mvolo, this is a village in South Sudan. This is on the left side, you see an image of a person, it's an entomologist who was there in 1948. And he described that this was a site in South Sudan with extremely high biting rates and extremely high infection rates of the black flies. That was very well documented at that time. But he wrote also that this Mvolo was only a police station, and there was really very few people living there. There was not really a village or a town. When I was there in 2013, it was really nearly a town, quite a large number of people living there. And when I went to the river, and it's exactly the same place as where this guy is sitting, exactly in the same place, you see all the children swimming. But it was not only swimming children that I saw, but I saw men fishing. It was a marvelous fishing place. You see the women selling the fish, so it was enough food. So it was clear that nodding syndrome is not a question of food problem. And you have the women cleaning their clothes. And so the entire village was in that place. But that place is also a black fly breeding site. And what I think is that happens in South Sudan is that in the past, because of the black fly breeding sites and the nuisance with the bites, and also the knowledge that you can then it can cause blindness, people were moving away from the river. And so even certain villages were abandoned that were close to rivers. But now, because of poverty, because of war, because of people needed food, they go to those places where the river is, where there are opportunities for fishing, and also good farmland. Good farmland is often close to rivers. So they forgot that those places are dangerous for your health, and these villages were growing, and with growing villages, you got also increasing numbers of epilepsy. Now, the situation may be different in each country, it may be different, and I will show you later another example of increase of an epidemic of nodding syndrome. And I want to go back to Uganda, where indeed in the north there was an important epidemic in the late 1990s, and the reason for that epidemic is still not 100% clear. It is clear that it was also happening during a war, and people were put in IDP camps, hundreds and thousands of people, and there could have been malnutrition and so in that period. But I think another consideration should be that that at a certain point in 1986, more than 300,000 cattle were stolen from those Acholi people in that area. And that, I think, could also have caused an increase of onchocerciasis transmission. Indeed, black flies they may also bite cattle instead of humans when they are there, and they also transmit another form of onchocerciasis. And if they then transmit that other form of onchocerciasis to humans, the humans get the antibodies. They will not develop disease, but they develop antibodies against these other form of onchocerciasis. But it has been shown that these antibodies also protect to some degree to Onchocerca volvulus, so the cause of onchocerciasis in humans. And moreover, these cattle are grazing along the rivers, and so there is not enough shade, and the black flies may die earlier. So if you remove the black flies, you can see an increase of transmission of onchocerciasis, and that can be followed several years later by epilepsy. That is still a hypothesis that needs to be proven. Now, if you think that onchocerciasis is the trigger of epilepsy, then the obvious thing to do is to see whether you can, by eliminating onchocerciasis, also eliminate this form of epilepsy. So we have been looking in several places now to see whether that onchocerciasis elimination effort had an effect on the incidence of epilepsy. And for example, in Cameroon, we went to two villages, Bilomo and Keleng. And in Keleng, there was the advantage that there was an epilepsy survey done more than 13 years ago. And you see that when we went back in 2018, that the incidence of epilepsy decreased enormously, from 774 to 98, and that was clearly significant. So most likely because of the onchocerciasis elimination effort. And we also saw, for example, in Bilomo, where we had no data of incidence of ivermectin of epilepsy in before, we saw an increase of the prevalence of epilepsy in the older age groups. And that was not significant in Keleng because that is a very small village, so it's difficult to show a difference. But in Bilomo and also in other places where we've been, that is what is happening, that if you start treating distributing ivermectin in the population, you have less children who develop epilepsy in the age group 3 to 18 years old. But those who developed epilepsy in the past, they may still be alive, and now instead of being below 18, they become above 18. So you see that increase of the prevalence is now increasing seen in the older age group, suggesting again that the distribution of ivermectin has an effect on the incidence of epilepsy. Now, it's not in all places that you see that the community directed distribution of ivermectin, CDTI, has an effect on the epilepsy. For example, we went also to Mahenge in Tanzania. That is the place where in 1960 the nodding syndrome was detected. And it was clear that at that time already there was a lot of epilepsy in the area, but nothing has been done. So at that time, it was not known that there was a relationship between onchocerciasis and epilepsy. It was certainly not accepted as something that should be addressed. And what is the consequence? When we went there, we saw that after 20 years of CDTI, there was a very high prevalence, still a high prevalence of epilepsy. For example, in Mdindo, these are rural villages, and you have an epilepsy prevalence of 3.5%. And that was much higher than in the town, close to Mahenge, where it was only 1.6%. And we saw also that those rural villages had high prevalence of epilepsy, but also high prevalence. More than 30% of the children below the age of 10 were positive for antibodies against onchocerciasis. Now, if you have children at that young age that already have antibodies, it means there is ongoing transmission. Older people have antibodies, but that's because they have been exposed in the past and they have antibodies. They stay there for a while. But if you find antibodies in a young child, it means active transmission. So the problem is not solved there, despite 20 years of CDTI. And in fact, if we looked at the black flies and the infection rate and the infectivity of the black flies, then we see that they are still very high, 1.65 in Sali. And these numbers are comparable with numbers of entomologists that have been investigated that area more than 20 years ago. So despite 20 years of CDTI, nothing changed in Maridi, in that area. And that is because, in fact, we found out that the coverage of ivermectin was really low and that there was no good distribution of ivermectin in that area. And again, in Tanzania and all these places where we've been, in all the countries where we've been, we saw the same image that I showed you in Congo. That's always associated, the nodding syndrome, the Nakalanga syndrome, and other forms of epilepsy. So you find these things in areas where there's a high level of epilepsy in onco areas. And here, for example, that is in Volo, in South Sudan. That boy, 26 years old, it looks like 8 years old. He was called Akulu Kulu. It means the one who's eating a lot, but is not growing. So it's not a nutritional problem. This type of people, there's no other disease that is explaining that. It is certainly not a nutritional factor, but it is also associated with some thoracic and spinal abnormalities. So to see the burden of disease and to convince you of the problem caused by this form of epilepsy, you have to go to South Sudan, because there is a terrible problem. And you see that on this slide. We went to Maridi in South Sudan, and you saw in different villages in Maridi extremely high prevalences, up to 11.9% in Kazana 2. Of that village was affected by epilepsy. So that village, you can imagine, has no future. There's nobody for going and working the farms. That is enormous if you consider all the psychosocial economic consequences of epilepsy in that village. And where is that village located? That village, Kazana 2, is there in pink, and Kazana 3, the one is also high prevalence in brown. And you see in the middle, you see a dam. And in fact, so in that area, Kazana 2, you have also this person living, a 20-year-old boy. And if you are still not convinced that what I explained you, nodding syndrome, and Nakalanga and epilepsy is the same disease, I hope, and that it's related to onco, only this image will convince you of the fact that all that is associated with onco. Indeed, that's a boy who developed already blindness, and you see the eyes here, at 7 years old, and it's a typical blindness of onchocerciasis. At the age of 10, he started the nodding, and you see he was not growing. He's only 27 kilos, 1 meter 30. He has in his family 4 other siblings with epilepsy, and already one died, and some had nodding, and others had other forms of epilepsy. So I don't think this boy has 3 diseases, one causing the eye disease, another cause the nodding, and another cause the stunting. So I think, and that family is affected. And why is the family infected? Because they lived in Kazana, and Kazana is close to the dam, and the dam is even Kazana Dam, and the flies, the black flies, are called by the local people as Kazana flies. So it's clear we need to do something. And what we need to do is to give ivermectin. As you know, the ivermectin is killing very rapidly the microfilaria. And so if there's no microfilaria, I think the trigger is not there to cause the epilepsy. But we have tried in Maridi to get twice a year ivermectin, to increase the coverage, to have everybody covered with ivermectin, it's extremely difficult to get it. But we found out another way to control the onchocerciasis, and at the long term, I think it's also very positive. We found a way, and we call it slash and clear. And you see, these guys, these are volunteers, to eliminate all the vegetation at the Maridi Dam. So this is the water coming down from the dam. And we had found with the entomologist from Uganda, Tom Lakwo, that this is the only place where the black fly breeding site is in that area. So there, I think if we again talk about where are these epidemics coming from, we could trace that, in fact, indeed, the increase of epilepsy in that area was linked to the making of the dam and improving the dam. And that was indeed, this dam is an ideal place for breeding site, because there are a lot of oxygen in this water, and so you have a lot of larvae, and these guys, they are now eliminating the vegetation. And on the right side of the slide, you see that there was extremely high biting rates, like monthly biting rates were more than 6,000 per month per person, and that decreased rapidly after the slash and clear, and the black fly stayed away for a long period. It's only after 1 year that they come back, but at a much lower level, more than 50% lower level than initial. So we think that if we do it once a year or even twice a year, that we can get rid of the flies, and that probably we could decrease also the incidence of, if we combine that with twice a year ivermectin, we could stop epilepsy and nodding syndrome in that area. Now, often people tell me, yeah, but why is there no epilepsy and nodding syndrome in West Africa? Now, I can tell you there has been also epilepsy in West Africa, and we found that in some old literature, and I have no time to go in detail there, but I will only show you this slide. This has been a study done in people from West Africa, and it's a very large study with more than 290,000 people where skin snips were done, and they looked at the number of microfilarial load in those individuals, and the outcome, mortality over time on the y-axis. And there was something very special what they found. If they looked at people below the age of 20 and the people above the age of 20, they found a higher risk of dying in the young people compared with the old. So they see that the mortality is increasing with the number of microfilaria, but if you compare the young with the old, it's the young people who die. Now, the young people are certainly not dying because they are blind. They are not dying because they have skin lesions. So I think the only obvious explanation is that the young people die because young people, as I explained you, develop epilepsy. And we know that epilepsy, particularly in those areas where often there is no treatment, they die quickly. And that is, to me, the explanation about this difference of mortality with the age groups, but also shows that it was also a problem in the past in West Africa. But as you know, in West Africa, it has been very good onchocerciasis elimination with the use of insecticides and also CDTI. So that's the reason that now, for the moment, indeed, there's not a problem of epilepsy in that area. But in the past, it certainly also happened there. Now, if you are still not convinced about the association, I think I have still two important studies. In fact, there are three important studies that also show the association. And that is, first is a cohort study. Because indeed, so far, a lot of investigations have looked at cross-sectional studies and case control studies. And if you do that, it's very difficult to show association. You need to have prospective studies. But that was possible in Cameroon because more than 25 years ago, our colleague Michel Boussinex has taken skin snips in small children between the age of 5 and 10. And 20 years later, we went back to these families and to find these children and to try to find out whether they developed epilepsy or not. And more than 80% of the families, we could trace what happened with these children. And we saw that there is a clear relationship with the number of microfilariae in the skin and the incidence of epilepsy. You see that the incidence of epilepsy increases with increasing number of microfilariae in the skin in the past. And if you have more than 200 microfilariae in the skin, your risk is more than 28 times than the risk for developing epilepsy than if you have no microfilariae in your skin. So that is in a prospective study. We see a dose response and also a time response that it is the number of microfilariae in the skin that is a determinant of development later of epilepsy. And then the second, and this has been now shown in another cohort study also in that area. Another important study is a study we have done in 2018 in Cameroon, and it has been done with Dr. Kaiser, who is here in the middle, and here's a research team. We went to a place where in 1994, Dr. Kaiser had done an epilepsy prevalence study, and you see on the left the area in black is the area very close to the river, and there was a prevalence of 3%. And he found also a case of nodding and nakalanga in that area. Now we went back in 2018 and we saw that we went back from house to house and we saw that indeed the epilepsy prevalence went down, but that there was no more nodding syndrome and no onchocerciasis-associated epilepsy, no more nakalanga that appeared after 2004. And you see it here on the slide. After 2004, why 2004? Because 2004, it was declared by WHO that there was no more onchocerciasis in that area. In fact, even the vector had disappeared. And you see that that indeed the prevalence decreased in that area from 3% to 1.2%. But moreover, in the age group 10 to 19, and I explained that is the age group where you see the onchocerciasis-associated epilepsy, there it was really the same as in the general population, it was about 1%. So if you eliminate onchocerciasis, then you eliminate this type of epilepsy. Now that was for prevention. I hope it's clear that we can prevent this form of epilepsy. Now, what can we do for treatment? That's more complicated because epilepsy is difficult to treat. You can treat it, but you cannot cure it. And this is the same with this form of epilepsy related to onchocerciasis. But we did a trial in Ituri, in the Congo, and because we wanted to see whether ivermectin had an effect on the frequency of seizures. Because I was reported by anecdotal reports that this could have an effect. And indeed, we compared once a year treatment of ivermectin and 2 or 3 times a year. And we saw indeed that those who received ivermectin 3 times a year, 2 or 3 times a year, had less seizures at the end than those who received it only once. And that was related to the decrease of microfilarial load. This again is an element to think that, suggesting that it is this form of epilepsy is related to the microfilarial load in the body. But this was a very interesting exercise also. We were not only treating people with epilepsy who were onco-positive, we were treating the entire village. So this was an exercise to treat in a very rural area, a very difficult area, mountainous areas, and there's a lot of insecurity now even, to treat people with epilepsy. And we had to do it with involving the community workers that the CDTDs, so the distributors of ivermectin, were included to detect epilepsy and to follow adherence with anti-epileptic treatment. And we trained the nurses to give the treatment under supervision of the doctors. and it worked quite well. It started 2 years ago. I don't know how sustainable it is because we had some external funding, but I hear it's still ongoing for the moment. So I'm nearly at the end, but you will ask what is now the pathophysiology of this onchocerciasis-associated epilepsy. And there I must say, I don't know. We still don't know. We did post-mortem studies, and you see on the slide some histological pictures. We did a lot of investigations on cerebrospinal fluid, on the brain samples, etc. But so far, I must admit that we don't know exactly what is the mechanism. It's certainly not the microfilariae or the worm itself is going directly to the brain. That we can exclude, and you see on the slide that many other hypotheses also were excluded. So research still need to go on, and we are still very busy of trying to do that. But I think the most important thing for this group of audiences is what is now the message for the neglected disease control programs. And I think there's a very important messages for you. And that is, first, I think, I hope I convince you that the burden of disease caused by onchocerciasis is much, much bigger than considered currently. Because currently, for the burden of disease is only the skin lesions and the blindness that is considered. And skin lesions in general is not causing a lot of DALYs, and the blindness, that indeed, I agree, has been reduced a lot by the onchocerciasis control programs. But epilepsy is still there, and epilepsy is associated with huge psychosocial economic consequences and disabilities. And so we cannot say that onchocerciasis is not a public health problem anymore. In South Sudan, it's the major public health problem. I think it's more important than HIV, TB, and malaria together for that village close to the Kazana Dam. So it's clear we need more funding for those poor areas, like in South Sudan. We also need more, if some people still don't accept the association, please let us then also try to find extra funding. So far, I must say all the funding, I provide all the funding myself with the help of European Union mainly, and really this need to be changed. It need to be considered. This issue need to be considered as a major problem to address. So and we need also a shift of the NTD program. We need to shift, and that is I hear now that in the new WHO roadmap is a very important point. Indeed, we need to shift to outcome parameters that are instead of process parameters, and we have such a nice outcome parameter, and that's onchocerciasis-associated morbidity. It's the epilepsy is something that can be measured very easily. And so I think there is now a shift that's needed. There is a lot of interest and a lot of money from Gates Foundation, other organizations, to elimination and elimination mapping to see where is there still a little bit of onchocerciasis. But it is clear where the disease is, like in South Sudan, we know in Maridi, this is a major problem. And it's not only Maridi, but there are many places in South Sudan where there's a major problem of epilepsy and also still blindness. And we need to go there and treat there and improve the elimination efforts there. And we should try to give the CTTI twice a year. They've done it in northern Uganda, and very quickly, in 1 year or so, the nodding syndrome stopped. And even we need to consider vector control. I showed you that it can be done in some places very effectively and very cheap with the slash and clear mechanism at the dam, for example. And the onchocerciasis elimination program will be much, much more cost-effective and beneficial if you do it in areas where there's a lot of morbidity and mortality. Because you're not eliminating the parasite, but you're improving the life of the people. You save the people, and you avoid the disabilities caused by onchocerciasis. And then the second message, and that is also a message now in the roadmap, important for NTD programs, that is the collaboration, the multidisciplinary approach. And and it should go further than only a multidisciplinary approach between onchocerciasis and WASH and other eliminations of parasites. But it should be, for example, a collaboration here between the onco control program and the NTD program and the mental health program, because we have to look at where are the cases of epilepsy. If you see, and what we have done, we went to many places where it was not known there was onco, where there is even no ivermectin. We found a lot of epilepsy, and then we found later that this was a hotspot for onchocerciasis. So both programs can help each other. On the other side, if you find a place where CDTI is interrupted, where the program is not working, you can expect a lot of epilepsy. So these people need epileptic treatment in those areas. And often there are no doctors, no neurologists, so people don't know that this disease can be treated. So it's also clear, and we have experienced that in many places, that onchocerciasis-associated epilepsy and epilepsy in general is considered still as a disease that is caused by some evil sources, evil causes, and families are cursed because there are several cases in one family. If you explain to that population why several people in the family, for example, in Kazana, close to the river, have all epilepsy, and you explain that this is because of the black fly, then they will understand that this is a disease caused by a parasite, and that not by an evil spirit, and that it is also not transmitted from one child to another in the family, so that they can eat together, they can sleep together. So you will decrease the stigma associated with epilepsy. But moreover, if they know that now you can prevent the development of epilepsy, it will stimulate them to take the ivermectin. And we've seen that it's so difficult to get big coverage, but it's because the people, if you say this, it avoids blindness or skin disease, that will not be extremely motivated for the family to take the ivermectin. But if you say it like in Maridi, we are now explaining why these people have epilepsy, I'm sure we will increase coverage, and we have already increased coverage in those areas. So I'm now at my final slides. Sorry that I went on so long, but you hear from me that I want to convince you to change something. There is onchocerciasis-associated epilepsy. I think it's a major neglected disease. It's even so neglected that it's even not considered as a neglected disease. And it should be taken into account in the roadmap. And in fact, that's in fact what we are doing in South Sudan for the moment. It's preventable and treatable, and it was already mentioned by Cameron. It was already discovered, this association between epilepsy and onchocerciasis in 1938, when there was still onchocerciasis in Mexico. So I think it's now time for action after so many years. This was my last slide, and then I have the slide for thanks to many people. I was very lucky to have support from the ERC, the European Research Council, for my funding, and also got funding from the Belgian government. And you see here in all the countries where we have collaborators, excellent scientists, and we worked also with international experts. And I have also a list of many local collaborators from my university, the University of Antwerp. I thank you, and I'm very willing to respond to all your questions.
Okay, so thank you very, very much, Robert, for that. I'm sure all of you who just sat through that amazing presentation, what a journey that was. And I'm sure all of you can see exactly why we chose this particular topic. It really does play to the shifts in the WHO roadmap. It really sings to that, and the roadmap shifts sing to this, play to this in terms of some of the things that need to be kind of looked at in some detail. Certainly the questions that have been coming through thick and fast alluding to those shifts. I'm going to start the Q&A. Thank you very much, everybody, for staying on for the Q&A. I think it's very important, this part as well, to get some of this moving. One of the first, I wanted to kind of not theme, but obviously follow those three shifts and kind of shape the questions around those somewhat. So the kind of the first shift we've mentioned is this move in terms of accountability impact, the WHO roadmap shift, moving from action-driven to a more impact-driven. The question is, if this is to become the epilepsy, associated epilepsy, is to become a proxy measure for onco-prevalence, then, firstly, I mean, what are your views on that, Robert, in terms of the proxy measure for you're pushing for that, I'm assuming.
Yeah. So we have even a definition. There's a definition of nodding syndrome, and we have broadened that definition. It's a little bit similar, but where the age group of onset of epilepsy is important. They need to be healthy before. I see there's one of the questions also, have you ruled out malaria? Indeed. So we ask, you can only consider that onchocerciasis may be the trigger if there is there no other trigger or other cause. For example, cerebral malaria. If you have recently or cerebral malaria in the past, you can have epilepsy even many years later. So we tried always to exclude that, but we cannot exclude everything. And indeed, one disease that you have to exclude is neurocystic psychosis. So that's also very prevalent in many areas in Africa, but it's not prevalent in South Sudan because they are Muslims. And in the places where I've been, like in Maride, there are no peaks. There is no possibility to have neurocystic psychosis. So in those areas where I explained, it was very clear that there is that association with the dam and the black flies, and so they are really we are sure about what's going on there. Yeah. But I agree that in other places it may be more difficult. And so I think indeed we are still lacking a biomarker to say okay.
Yeah. This is what I was going to ask, because Dr. Kimengo Francis from Cameroon has made that point that obviously to make this a proxy measure, you need a clear association. Perhaps we're moving towards that, but Dr. Francis has made the point that onchocerciasis microfilari has not yet been found in the brain CSF. So perhaps the possible reason, or perhaps you could enlighten us in terms of the association to onco and epilepsy, is it possibly the autoimmune reaction, or is it the skin that's releasing the parasitic skin that's releasing some secretion, some products? We ruled out serotonin, and obviously 5-hydroxytryptamine receptors are implicated, the decline in 5-HT in seizures themselves. I think that's something that quite a few people are asking. Are there studies in this area? Is it something that the adult worm is secreting? Dr. Stephen Brahmian made the point that ivermectin obviously is affecting the young, the larval form. Is it the adult worm that's secreting something? What are your opinions on that?
Yeah, so concerning the immunological possibilities, there has been a publication suggesting some cross-reaction of antibodies against onco that could be neurotoxic, the leomodin. In our experience, that is not the cause. That is not playing a factor. So publications will come out very soon. So that is not the one. So there could be other antibodies, but I think it's a little bit strange that it would be really an autoimmune disease, because I've never seen really an epidemic of an autoimmune disease. So autoimmune disease is linked to genes and predisposition, and so I expect, yes, immunity certainly plays a role, and it has been also shown that there's some HLA relationship. So certain children with certain HLA may be more susceptible to develop nodding syndrome. That has been shown in one publication. I believe that's right. So indeed, because why are some children developing nodding syndrome and then the brother is not developing it or developing another form of epilepsy? So a lot of factors playing a role. There's not only one factor. It's in all diseases like that. So genetic factors play a role, but it's certainly not only genetic factor. So it's not a genetic disease. That's clear.
Okay. So in terms of, there's another question coming through in terms of the etiology. Stephen Brahmia from Canada is asking, does the manifestation of nodding and epilepsy precede or is it after the blindness and the skin nodules? At what point does the epilepsy start manifesting?
No. So the skin disease, and so the itching is very early, and then the itching is very early, but then and then around the age of 8, for the nodding it's a little bit early, because I think it's, and the Nakalanga is certainly also very early, because I think they're infected early and with high levels, and then they develop epilepsy around 10 years old, other forms of epilepsy. And then the blindness is much longer, so you need to have much more exposure and a long period and very high microcerebral load at a certain age. You develop blindness. I showed a boy who developed epilepsy and already blindness at the age of 10. That's extremely young. I see that Adrian Hopkins is also attending. He's the expert in the world of onchocerciasis and eye disease, and maybe he can say something about it. I think they have a boy that at 10 years old is already completely blind and have nothing, and so he is very infected. So the blindness is coming late, and then you have these late skin lesions also because of the scratching, and so that can also sometimes be late. But
that's a very interesting answer. And yes, we do have Dr. Adrian Hopkins there. I'm very happy and honored to have that. If anybody wants to, if you would like, I don't want to put you on the spot, but feel free to send any questions in or pop in at any point. We've got loads of questions here, and I just wanted to. So there's a lot in terms of the association between epilepsy from a molecular perspective. Let's say secretions, immune responses, but also from there's a question that's come through from Dr. Milena from the University of Salford in Manchester. Who's just, I believe, completed a PhD there. And I'm just trying to bring that up actually on the screen. It's really about the stigmas in terms of managing the mental health stigma, depression of children with nodding syndrome, Nakalanga syndrome, and onchocerciasis epilepsy. Is that something that would have affected the kind of, how to put this, she's asking, is this an inhibiting factor in terms of vector control programs in this region, that the stigmatization attached to nodding disease? She's worked in northern Pada region, and she's just asking, what are your views on the mental stigmas attached to this?
Yeah, indeed, there's a lot of stigma. First, onchocerciasis already has some stigma because of the skin disease and so on. So that's already since well known that onchocerciasis, but epilepsy, that's worse. That's much worse. All kinds of epilepsy, because this kind of nodding, whether it's now nodding or another forms of epilepsy, is associated with stigma. And why is it associated with stigma? For several reasons. First, if the cause is not known, the local people, they will say, oh, it's because something went wrong in the family, and so the family is cursed. It is the evil spirits. So that we once we say this is, and therefore I'm sometimes upset of some of my colleague researchers or other people that say this is a mysterious disease. For me, it's not a mysterious disease. If it's a mysterious disease, that is for the traditional healer. And we want to move away from these traditional healers. We can work with them, but they need to understand that this is something you can prevent and you can treat. Particularly epilepsy needs to be treated with anti-epileptic drugs. So indeed, the stigma is a problem, but I think for control of onchocerciasis, I think it's more an advantage that this is an extremely serious problem. In South Sudan, I must say this. It was not my initiative to go there and to do research. I was called in because of Amref, who is there on site, and because the government of South Sudan didn't know what to do, and they said, we have a major problem in Maridi. Can you help us? What can we do? And then I went there on site, and we indeed confirmed the major problem. And now we identified where the problem is. It's the dam. And now we're trying to do something about it. And so I think, there's a very good collaboration with the population. It's the mayor of Maridi, who is really a very advocate for onchocerciasis control. And I can tell you in Ituri, where we started this epilepsy treatment, we had T-shirts. We said on the T-shirt we put on, fight onchocerciasis and epilepsy, one fight. Huh?
Yeah, and that's a very interesting point because it kind of brings us to the second shift, this whole movement from a vertical approach to a cross-cutting, cross-sectorial approach. You put some messages out there for the NTD world. What would be your message to the epilepsy world? I say that because on Monday is International Epilepsy Day, and we're going to be releasing this video asset as part of and some advocacy that we're going to be doing this particular session on Monday out to the wider world, and in particular the epilepsy, pediatric epilepsy, and that type of community from Monday onwards. What would be your message to them?
Yeah, the message is that we have seen in all those remote areas, there's no treatment, or people are interrupting the treatment. It's very costly for the family. In fact, we also documented that they go to the traditional healer, and that is very, very costly. Mm-hmm. So by giving them a very cheap drug like phenobarbital, that's only costing a few dollars for treating the person a whole year. Then they don't spend the huge fortunes for traditional healers, or going to a center in the capital of the city of the country or so. So indeed we can do a lot for the people with epilepsy, but I know that the International Society for Epilepsy, they are aware of the problem of epilepsy in Africa and the challenges, but they are not aware, and they're still not convinced that this epilepsy can be related with onchocerciasis. Mm-hmm. And I think the message is that they should go to those places in onchocerciasis areas because they need the treatment, and they need training of the nurses there, especially in these areas where there's so much epilepsy. So it was not known when we went to the Congo. It was not known that there was so much epilepsy in these areas.
So, staying within this kind of multi-sectorial shift, but moving away from epilepsy for a second, environmental engineering, the Maridi Dam slides that you showed, we had a couple of questions come in, again from Dr. Nikemo Francis from the Cameroon. Would slash and clear method be a good option in fast-flowing rapids, such as the Mbam focus in Cameroon? Yeah. Because sometimes the black fly larva may be developing in inaccessible depths. I know there was a paper in PLOS a few weeks ago, PLOS NTDs, regarding oncoprevalence post-MDA, looking at the Mbam dam itself. And then Stephen's also asking, Dr. Stephen Brahmier is asking, in addition to cutting the aquatic vegetations at the downstream area of dams, periodic release of water from the dam also reduces the population of black fly larvae. He was involved in a project in Ghana that was doing this. So,
concerning,
so what are your views around the engineering side?
Are you hearing me still?
Yeah, we loud and clear. Yeah.
Okay, so concerning Cameroon, the Bam Valley is a big river, so indeed it may be more difficult to do slash and clear in some places. I'm fully aware that we in Maridi had an extremely excellent case there. I must say that with 4 persons working during 4 or 5 days, they did the job very well. So that may not be the case in other places, indeed. But I have my PhD student who is now a postdoc and who is now working in Cameroon, who has now a grant from the EDCTP, from the Europe, to do a trial, to just look at several places in Cameroon. First, to see whether the slash and clear works. And second, to see whether it has an effect, like you say, on transmission, but also on disease, on epilepsy. So he's going to see whether it works. We don't know whether it works. And I have just written also a proposal together with the colleagues from South Sudan for Ascent, a proposal to do slash and clear in several places, not only Maridi, but to repeat the thing in other sites. The problem is that the grant, we don't know where we'll get the grant. And second, it was only a grant for 4 months. Okay. So we certainly, if it's successful, we would like to do a long-term follow-up.
Well, fingers crossed, and I think you're definitely making the case for that type of approach. Stephen Bramia has put a statement there saying black fly larvae feed efficiently at specific water velocities. Periodic release of water from the dams varies the flow velocity and therefore disrupts the ability of the larva to feed. So there's something to kind of throw into the mix there. We've had a question, or rather something come in from Dr. Adrian Hopkins. He said, even if I suppose this is alluding to the relationship between epilepsy and the onchocerciasis. And Dr. Hopkins is saying, even if we do not understand the causal relationship, we do know of the association. So we do need to concentrate on onchocerciasis hotspots for ivermectin treatment 2 times a year and prioritize these areas. So there is some form of recommendation going out to alter perhaps or slightly change the mass drug administration programs, taking this type of thing into consideration based on the association that is certainly evident from what you've shown us today and the historic literature on this as well. There are a lot of people saying thank you very much for a very, very interesting presentation. Professor Louise Kelly Hope from the Liverpool School of Tropical Medicine is saying, just popping back to the autoimmune processes or the kind of molecular side of things, Professor David Taylor from the University of Edinburgh, if autoimmune processes are involved, it should be possible to identify antibody T-cell cross-reactivity between the parasite and neural tissue. He's mentioning a study in 1991 by Gabby Braun demonstrated that immunological cross-reactivity between a defined oncovolvulus antigen and a 44 kD protein of retinal pigment epithelium. He's mentioned that study. And the inference is that autoimmune processes may lead to eye disease. So made a point that today's molecular technology should allow relatively easy identification for such interactions. So perhaps a new road in terms of using the roadmap to, again, apply different platforms and different technologies to this multi-sectorial, movement.
Yes.
So that's something.
So we are also looking at autoimmune possibilities and testing a lot of antibodies, and the results are not yet out. We're working with Martin Tutelaar of the Netherlands, but if there are people now in the audience like Taylor that want to be in contact with me, we can have conversation by email about other possibilities. We have the samples, so we are looking for more new collaborations and new ideas in this domain.
And may I ask you, Robert, would you be open to anybody emailing you?
No problem. You can share my email with everybody. Yeah?
Fantastic. So you have that.
I would like to, because I have no time to read everything. I see there's a lot of interest, and maybe also people that have not been attending this session, they could also contact me later.
We're certainly going to be putting the video out from Monday onwards. Dr. Kisito Ogusan from Washington, part of the FHI 360 setup there, is saying that since we have at least a protocol to care for patients, how can we broadly screen it with simple techniques in terms of cost-effective techniques highly specific to nodding syndrome? He's saying that we have care protocols for these patients. How can we involve or perhaps develop a broad screening protocol specific to nodding syndrome to these patients? I mean, I suppose that's another thing to consider. People already exist. He's saying, how can we do that? What would you suggest in terms of a cost-effective screening technique that could be broadly applied to those people? So that's an interesting thing. Dr. Enrique Padial from, I believe, Mexico is saying, what an interesting presentation. In his experience in Equatorial Guinea, there's a high prevalence of epilepsy and onchocerciasis in 2012, but no one had suggested this association with ivermectin, so thank you very much for that. So Dr. Helena Helmby from London, very informative talk and very interesting, thank you. So that's great. Some very interesting. He's also asking, do you think there can be a relationship with African trypanosomosis in other areas with ivermectin coverage that have a lower incidence of trypanosome disease? I'm not sure. I think that's going into a little. He's asking if there's a relationship between African trypanosomosis. I'm not sure if you got that question or not on your screen, but we can, have a look at that. Perhaps it might be good, Enrique, to get in touch directly with Robert about that. Dr. Hopkins is saying,
I can answer some of the questions. So about screening, I don't know what the question exactly is. Is it screening for diagnosis? I think to find the case is not difficult. Epilepsy, those areas, onchocerciasis areas, the families are very well knowledgeable about what epilepsy is. I'm not saying that it can be misdiagnosed sometimes, but it's not too difficult to diagnose nodding syndrome and other forms of epilepsy. Again, I want to say that we should not concentrate only on nodding syndrome. I prefer to talk about nodding seizures. We have to describe simply what we see, what kind of seizures we see, and we should detect epilepsy in general in these areas and treat everybody now for epilepsy, whether they have nodding seizures or other disease. I agree that probably, and also more research could be done, that nodding seizures may react less, for example, to phenobarbital. And we prefer valproate in general for nodding seizures, but that is much more expensive. So the neurologists indeed have a point that there may be other protocols needed for treating nodding cases. But also phenobarbital, if you give it already, it will do something. It's very important because these children, they start with nodding, but after a while they also develop generalized seizures. Most of them, and even the nodding can disappear and they develop generalized seizures. So phenobarbital is already a good starting point, and if we can get all those areas enough phenobarbital and maybe carbamazepine, it will be already a big advantage. So that is, I think, indeed we have to have, but WHO has programs for decentralization of epileptic treatment, and this should be implemented, and nurses should take over from doctors, because there are no doctors and certainly no neurologists in those areas. Then the question about Guinea and about West Africa, indeed, there are still some places where there's epilepsy, and that was considered in the past, for example, as genetic. And that we found out if you go and see the records, and some of the gray literature we found, for example, in Cote d'Ivoire, and we published that there were families with a lot of epilepsy cases, and if you then read that, you say, oh, but this is related to onchocerciasis, and then if you see on the map, the village is located close to a rapid flowing river, and so there have been a lot of misdiagnoses in the past, also in West Africa. So that's one. Then concerning the trypanosomiasis, for me, I don't think there is a relationship, but I have between trypanosomiasis and nodding syndrome, or indeed, it's trypanosomiasis is also a neurological disease. But for example, I've been in a place in northern Congo, close to Dingula, and there was a treatment center for trypanosomiasis by MSF, and they did a trial on trypanosomiasis. There were no cases, but they didn't know that in the Dingula was full of epilepsy because of onchocerciasis. So indeed, onchocerciasis also in areas far away and close to the rivers, and so the ecology can be similar. And but I think trypanosomiasis, I think indeed that's also, there's so much money for trypanosomiasis and for eliminating the last case. And if you see the degree of epilepsy caused by onchocerciasis, but we estimated between 100 and 400,000. But I think it's even more. I think if you see the numbers of people that are considered to be blind because of onchocerciasis, in all the villages where I've been, there are like 1% maybe people blind, and you have 5% who are epilepsy. So it's much worse than the blindness. In fact, it should be called river epilepsy. And yes, okay, river blindness is okay also, but it should be called a river epilepsy.
River epilepsy. John Gibb has from ex-DFID. I'm sure a lot of people on this will know John Gibb from his time at DFID. He's saying, thank you very much for this enlightening presentation. How to attract the authorities' attention to take the lead, which is kind of the last shift in the WHO roadmap, moving from an external lead into a much more sovereign, country-owned, approach to these programs. How do you catalyze political will? What's your view on that?
My experience is there is no problem at all with the local people. The local authorities, they're completely in favor of it. So in South Sudan, it's the South Sudanese government who asked my advice. The South Sudan is pushing for having the treatment there. There's no problem at all. They're 100%. And if you then go even worse, if you go to the mayor of Maridi, he's going from house to house with us to find, and he is trying really to do something for his village. So that's no problem. The same in the Congo. We have been with Dr. Tepaje from house to house. So the local people, they in the village, they know exactly what's going on. So it is at the very high level that the problem is to convince the colleague scientists. It's to convince. That's the first thing. The colleague science is the first, and then the second thing is then. Indeed, the decision makers at a higher level, and this is not a critique on the onco control program, the epilepsy, but the issue is that they don't work together. That's the problem. So people working on onchocerciasis at the highest level, they know there is indeed an epilepsy problem, but they don't want to address it because they say that's not their task. Their task is the parasite, and so they concentrate on the parasite and elimination of parasite. But I have a background on HIV, so I've been a fighter for the patient. I put the patient. But the patient, that's epilepsy. Indeed, that's another department at WHO. That's another. So this complete organization. They don't want even to say something, but because they may give. That's a problem.
Well, certainly, there's certainly more positive. The roadmap itself is an incredibly positive development, and I think it's really going to help to catalyze the movement. As I said right at the beginning of this presentation and before the Q&A, this topic really sang out to us in terms of the application of those 3 shifts. It really will impact this area, we feel. So we hope that from this kind of this today's session, you're going to get a lot of emails coming in, a lot of dialogue, a lot of crosstalk, and hopefully lead to something very, very interesting at the end of it. We've still got lots of stuff coming through, but I think I'm very aware of the time right now. It's coming up to 3:30, and we are going to have to call it a day. You've heard it. Dr. Adrian Hopkins has put some other bits out here saying, and I'll read those out. Dr. The Yanomami on the Brazil-Venezuela border in the Amazon have in fact received twice-yearly treatments for many years, and in some areas receiving 4 times per year treatments, referring to the ivermectin, the treatments there, the mass drug administration programs. And I see that there's been some cross-talk in terms of some of the attendants with each other, which is great, excellent. Dr. Delna Gandhi, ex-DFID, thanks a lot, very interesting, good luck with the ongoing work. Dr. Milena, thank you, extremely informative. Hopefully research in onchocerciasis, epilepsy, nodding syndrome provides hope for the communities in the endemic regions. Very, very positive feedback from everybody who's attended this. And we're really going to put this forward to the epilepsy world from Monday onwards in line with the International Epilepsy Day. And I'm sure that the MDA programs, and we've got the CBM, Christian Blind Mission, are on this as part of the attendees. I'm sure the MDA kind of programs that are out there are going to view this. I'm sure they are after this. We'll certainly be pushing the advocacy for that in terms of this video asset. I think, with your permission, Dr. Colebunders, I'm going to have to call it a day, if that's okay with you. I'd like to say thank you very, very much for a superb presentation. It's got everybody thinking along the lines of why we love the WHO's roadmap is that was a consensus-based, derived on consensus with everybody's input. So it's really reflective, of what's happening out there in terms of the global health community. So you get this instant resonance in terms of that is how people are, because they were the ones who inputted into that. It's not a prescriptive document. So I think there's a lot of hope in that. And we really wanted to put that onto this. So we really appreciate that. Dr. Henk Schallig, one of the in diagnostics from the University of Amsterdam. Henk, great to see you. Excellent presentation and a very good informative session. Thank you in capitals from the Academic Medical Center, Parasitology Unit at the University of Amsterdam. Dr. Lee Haynes from the Liverpool School. Extraordinary, eye-opening journey you have brought us on. Thank you. And we salute you too, Dr. Haynes there. Dr. Solomon Wafola, great webinar, Bob. Thank you. Dr. Kirengo Francis, thank you, Robert, for the excellent presentation. It really was superb. And so many people are saying thank you for that. And if I've missed anybody out, I'm very sorry for that, but we're, really appreciate everybody coming to that. I'd like to say thank you from us. And also that on the 11th of February, we have a very special full day program. We've partnered with Médecins Sans Frontières, MSF. We're looking at the polymicrobial disease NOMA, which is absolutely neglected. There are hardly any basic research processes in place regarding that particular disease, and yet it's affecting a large area of the Sahel with several focal areas. One of them is in Nigeria. We've got the Minister of Health for Nigeria as part of that presentation. Please join us for that. You're going to see a very, very special day on the 11th of February. And obviously join us every week for ISNTD Connect. We also have our Drug Discovery, Development and Diagnostics annual meeting on the 24th and 25th, all virtual. You're all welcome to join that. Thank you all very, very much indeed. A round of applause to yourself, Robert. Okay. Yeah, and a round of applause to all the attendees. Thank you so much. All right. Take care, everybody. Take care.
Bye-bye.
Bye-bye. Bye-bye.